just review a little bit about ratios and proportions. Ratios are basically when we have the same unit. So it's when we have compare sizes a lot of times. So maybe your foot length compared to your head length, okay? So there's a ratio, and we kind of did a project on this. Remember when we measured some of our different body heights and lengths and stuff? And we are proportionate. We have different ratios that are true. So it's the same measurement. Ratios are always the same unit divided by the same unit. That is how they are different than rates. Rates are the different units. They have to be different units, like dollars per gallon. That's two different, dollars are different units than gallons are. So that's a rate. How many dollars per gallon is the cost of gas? But a ratio always has the same unit. So when we're talking about ratios, and we're talking about ratios in geometry, we're talking about the lengths of sides usually. Okay, so we are looking for the lengths of sides. And we're going to find out what's true in similar things. But ratios are usually comparing length to length, which is a very common ratio. We did that with, I think you guys did something where you looked at the length and the ratio of the head and stuff to the, can't remember. It's the big thing they're building for, instead of Mount Rushmore. It's the torso of, well, there's the one for Mount Rushmore. It was done in a ratio, but also they're doing the Crazy Horse, the one for the Indian, which I think we did an assignment where you measured some of that. So yeah, they have been working on it for years. I drove up when we were back there last summer. We just drove in and looked at it. We didn't pay any money. So we went and looked at it and said, oh, that's pretty, but it was nice. So anyway, that's what a ratio is. Always you're comparing two similar things, okay? Two of the same unit, okay? A proportion, can't spell it, okay, proportion is basically two ratios that are equal. Okay. So get out some paper so you can take notes. We're doing 10-1. So a proportion is two ratios that are equal. Now if you think about that, that's really just two equivalent fractions. Okay? It's really just two equivalent fractions. So there's lots of ways to do it, but if I have 33 over 99, that really is the same as 1/3, okay? Because 33 divided into 99 goes in 3 times, so it's the same as 1/3. They're equivalent fractions, okay? Very easy if they're both divisible into a nice number here, okay? But equivalent fractions can be used, okay? There are a couple ways. What we usually talk about is how to solve proportions. In other words, when I have two fractions that are equal with one of them unknown, okay, there's a couple ways to do the procedure. So let's say I have 33, now let's just do 1/3, much easier. 1/3, and I'm going to say I want to know, okay, if this one is 17, what size is this going to be? Okay, now it's not easy. We can't divide that into 17. That is one way of doing it. Take 3, divide it into 17, multiply it by 1, and you will get the right answer. Okay, so if I could find out what times 3 gives me 17 by dividing 3 into 17 and then multiplying this by the same number. That is one way to do it. Okay. Another way to do it is called the mean extremes property. And I think it's, it's just a way of doing it. Another way people have done it is they've gone and got this in as a decimal, make that 1/3. I should show you this first. So they do the division first, and then that's x over 17, so we multiply each side by 17, and that gives us the answer. So that's another way of doing it. Okay. Same idea. Okay. The last way, now I'm actually talking about it's called the means extreme. I don't really care if you know that, but I call it cross multiplication. Because what you're really doing when you have a fraction equal to a fraction, okay, you actually end up multiplying the two opposite ones. So 1 times 17 will equal this times this. So the other two opposite ones, which is 3x. So 17 equals 3x. 17 divided by 3 is equal to x. All of these are legitimate ways of finding how your proportion, okay? Any of them work. They will all give you the same answer. Because if you notice, this is 17 times 0.33, which is really 1/3, right? This is 17 divided by 3, which is really the same as multiplying by 1/3, okay? This is 17 divided by 3. Oh, it's the same thing as that, okay? Multiplying it by 1, okay? So it gives you the same answer, okay? So all of these things work. Doesn't matter which way you do it, okay? So so it's really going back into fractions. Proportions are really just fractions equaling equivalent fractions. That's what they are. Stuff you've worked with forever. Now we might throw in some variables and stuff like that, but it's still the same. Okay, they're equivalent fractions. So that's really all 10-1 is about. You're going to work on some equivalent fractions. You're going to work on solving them and knowing what a ratio is.
So
yeah, go ahead.
That 17, the means extreme.
Yes.
Wouldn't it be so? It's 1 times 17 divided by 3.
Well, yeah, that's another way of doing it. Okay. But what's really true is this times this equals this times this.
Mm-hmm.
So you do the two, one up above and one down below equals one up above and one down below. That's how I talk about it. So, okay. Okay, so we're going to 10-2. So there's a couple of you that on last week's assignment, I wrote something on. We are going to talk about similarity. So last week's assignment, you were asked if these two shapes were the same. And you said, no, they're similar, but not exactly, not congruent. Okay. Well, that's actually not a true statement. I know what you meant. The word similar means they're kind of the same, but not exactly the same. Similar in geometry has an actual different meaning. Okay. Similar figures in geometry are the same exact shape. But not necessarily the same size. Okay. One way to think of it is one is usually smaller or one is usually bigger than the other. So if you think of models, when something is a model of something, that is a similar figure. Okay, so if we're looking at similar shapes, you have to my easiest way to do it is just to do this. So this triangle ABC is similar to triangle DBF because notice it's just smaller than the others. Okay, what they have is the same angles. So this last one, there's a problem in your things about having the same angles. Okay, when they have the same angles but are not exactly the same size, they are similar. So in similar figures, all the angles are congruent. Okay, so in similar figures, all angles are congruent. So when we draw a plan for a house or plan for something that we want to build, we usually draw it to scale. Okay, when we draw it to scale, what we're actually doing is making a similar figure of it that's just a lot smaller. Okay, and we usually use a ratio. So when similar figures, they have the same ratio for all sides. In other words, all sides are proportional. That's all sides between the two figures. So in this case, if this is 2 and this is 1, and this is, let's see, 5, that's square root of 5. Oh well. Okay, I'll put the square root of 5. And this is 5 times the square root of 5. Okay. So if you look at the hypotenuses here, okay, if you look at the hypotenuses here, notice that this side would be proportional to that side because they're the same sides in the similar figure. So we would have this proportionate, the small to the large. I always write it this way so I remember which way I'm doing it, okay, because you can get yourself confused. So small is the square root of 5. The large is 5 square roots of 5. So the ratio between the sides of these two figures is going to be 1/5. Okay, so small to large is 1/5. That's the ratio between the sides. That means I can figure out what this length is. So that means 1/5 is the same as 2 to what? Okay, shouldn't be too hard to figure. What is 1/5 equal to 2 to?
Is that supposed to be E or F?
That's an F. But 2 here, this length 2, how long is BC? If the ratio is 1 to 5, it would be 5 times 2, which is 10. Okay, so 10 would be the length. So in this case, BC would equal 10 because here we have BF. This one would be BC. Same ratio. Okay, let's look. Now we have BD. BD, this is hard. I don't know if you can do it. To BA. The ratio is 1 to 5th. Well, BD is 1. What is BA going to be? 5. Okay, if the ratio is 1 to 5, then the ratio is 1 to 5. So our BA is also going to be 5. I didn't want you to take too long to think about that. So, in similar figures, their angles are always exactly the same. Their angles are congruent. And their sides are in the same ratio. Always in the same ratio. So if we match them up, we should be able to figure out what the ratio is between them, and then we can do it. It's just like a scale drawing. If you do 1 little square equals so many feet on your paper, then you know what size you have to make each side of your plan or the drawing, because you know how many feet it's going to be in real life. Okay, so similar figures, we use these all the time because we make plans for everything. You can go on and get all sorts of plans for making different furniture, different barns, houses, everything you can think of. You buy model kits. Those are built on a certain scale. In fact, they give you the scale of what it is a lot of times. What is this scale? How much does 1 centimeter equal, or whatever of that? Okay. So they always tell you a scale. That is the ratio that they're using. Questions on that? Okay. So that's really what you're going to work on in these sections, is just looking at the different things with similar figures. You're going to see if they are similar. Oh, okay. Well, we'll talk about that later. They do talk about some things that how you can dilate something or make it bigger. Okay, so you have a center of dilation, and then you go from there and you make out the similar figures. We'll talk about that later. Excuse me, because that's easier. That's a way of drawing something to scale if you can have it on paper. It's only a way to do it if you draw it on paper. Okay, so that's what we're actually looking at today, is just these 2 sections. So let me get, now we're going to work on a few at your desk. Okay, so turn your book, I'm going to turn this off.